Hello everybody out there. Let's continue on looking at the 8th grade level 2003 Gauss paper. We're on question number 18. How many numbers from the set -5, -4, -3, -2, so there's all the -5 up to +3, so we all go all the way through 0. Okay. Satisfy the inequality -3x squared is less than -14. Okay. So the way I see it, there's sort of two ways we can do this question. We have a finite list of numbers. We could just go ahead and check each one of them. Does -5 satisfy this inequality? Does x equal -4 satisfy this inequality? -3, -2, and so on. You can make a nice little chart. What's your x value? What's -3x squared? And then yes or no, is it less than -14? Another thing we could probably do is we could take this inequality and manipulate it so that instead of talking about something involving x squared, maybe we've got something involving just an x. Maybe an inequality saying, oh, x has to be greater than 2 or something like that, and then we'll know, okay, only 3 works. Or x has to be in absolute value less than 3, in which case -5 and -4 are out. So I'm going to go through both of them just because I think they both have merit. The first one, where we just check each case, that couldn't easily be done if we had a giant list or a list that had no pattern to it. Okay, but it's still, sometimes we're just interested in the quickest way to do this competition, and if you got a finite list, why not work it out? So let's go to our notepad, and we've got x -3x squared and -14, or is it less than -14? Okay, notice that to be less than -14, we're going to specifically want things like -15, -16. Don't be fooled, we're not looking for things like -7 or -9, that sort of stuff. -4, -3, -2, -1, 0, 1, 2, or 3. Alright, well, even if we wanted to, we could even add a middle column here where we just do x squared first. I think that'll be easiest for me, just because I'm having to do this in my head. I'm not going to use my calculator for this one. So x squared, that'll be 25. -3 times 25, that's -75. And that is definitely less than -14. Okay? 75 greater than 14, but when you start doing negatives, things flip around. So we have 16 here, 9, 4, 1. This is great practice. Do I know my squares? So -3, what's 3 times 16? That's 48. So we're looking at -48. Here we've got -27, -12, -3, 0, -3, -12, -27. So this one, not any of these middle 5, and this last one, so that's a total of 4 of them. So we're asked how many, not which ones, and so we're going to go with an answer of D. So that's how we could do it, just plugging in and checking each value. What if we had a bigger list? What would we have done? Well, we would have started with this inequality. This is what we want to have satisfied. Okay? And what I want to do is, instead of having a statement involving x squared, I want to manipulate it down in some way to a statement involving x. Okay? So I notice I've got -3x squared here. I want to get rid of that -3, so I can just talk about x squared. Okay? So I could divide by 3 on both sides. Actually, sorry, I could divide by -3 on both sides. Now, an interesting thing happens when I have, if I have a less than b, that means -b is going to be less than -a. The sign flips around. Maybe it's easier to see if I write it this way. -a becomes greater than -b. So, for example, if you have 2 less than 3, -2 is greater than -3. -3 is less than -2. So it flips around. So when we multiply or divide by negative numbers with inequalities, things flip around. And that's an important thing to know. Okay? So let's divide by -3 on both sides. The sign will flip around, and we'll get negative divided by negative, so we'll have 14 divided by 3 here. And that's a little over 4, instead of noticing that. I'm pointing out that it's bigger, the next integer that it's bigger than, just because we're only working with integers over here. So, and then divided by -3, so -3x squared divided by -3, we're just going to get x squared over here. Notice again that the sign of the inequality, the less than sign, flipped around, and now it's a greater than sign. Okay. Well, having this 4 over here will make it really easy to square root. So ultimately what we're looking for is x squared to be greater than 4. And if you want to, you can stop there and say, well, that rules out -2, -1, 0, 1, and 2, and the rest are all fine. Or we could go a step further. Now, if you go a step further, it's going to be kind of tricky, because we're going to want to cancel out this x squared here. Okay? And the way we cancel out squares is we square roots. But when you do a square root, you automatically, if you put it under that little square root sign, you are automatically saying, I'm only taking the positive value. Okay? So we have to be a little careful when we do this. Okay? So it's going to be involving a plus or a minus. And in fact, what we get is we split it up into 2 inequalities. Okay? So to square root, we can get x is greater than square root of 4, or -x is greater than square root of 4. Okay? And now if we just want things in terms of x, we'll bring the minus sign over, but things are going to flip around again. And of course, root 4 is just 2. So we'll have any x less than -2 or any x greater than 2. So that's 3 over here, and over here this is 5, -4, and -3. Again, giving us 4 answers. Giving us an answer of D. Okay? So at any point you could have stopped and said, all right, this makes it easier, I can go through the list a lot quicker. Or you could have broken it all the way down into x greater than 2, x less than -2. Maybe an intermediate step would be something like plus minus square root of x squared is greater than square root of 4. Okay, if you just want to, you have to include the plus minus in there, otherwise you'll be missing a whole bunch of cases. But when you cancel out a square root, you split it up into multiple inequalities. All right, so that was question number 18 on the 2003 Gauss paper, a grade 8 Gauss. And we're going to look at question number 19 in the next video. Thank you guys for watching, and I'll see you next time.